Okay, great. And then lastly, Flying High is coming up. Flying High is our annual hydrogen aviation event in November. Sponsorships start at just $250. So you really can't beat that. Tickets are only $30. So I also put the link in the chat for that. And now I'm going to bring on our amazing, distinguished speaker today. So today we have the honor of welcoming Josh McMorrow. Josh is the group CEO of Philomaxcap AG. I hope I said that right. And the executive chairman of GenH2, leading the global charge in scaling next gen liquid hydrogen infrastructure. And as many of us know, that is kind of the missing piece of the hydrogen aviation ecosystem. So, with executive roles at Air Liquide, Energy Vault, and Weatherford International, Josh brings decades of deep expertise in the energy sector and a sharp focus on clean tech innovation. So, without further ado, Josh, the stage is all yours. And I will ask everybody kindly keep your microphones and cameras muted until the end. If you do have a question, you can put it in the chat and then we'll get to those at the end. I will stop share. And Josh, the stage is all yours.
Great. Thank you, Danielle. Really, really great to be here with all of you. I'm a big fan of the HYSKY presentations. I've seen a number of them up to this point, and I love that they're all online for others to see ones that they haven't had a chance to see yet. So I'll take advantage of that for the ones that I haven't had a chance to see. I think I'm number 70, so I have my work cut out for me to catch up. As Danielle mentioned, I am the CEO of what is now called Path2 Hydrogen. We were called Philomaxcap, but we're now Path to Hydrogen. It is a listed company on the Frankfurt Stock Exchange, and I am based in Berlin, Germany. Although I am a Texas guy by background, so I grew up in Houston, where Danielle is now, and worked for many years there, and then moved with my family to Europe, first to Switzerland, and then to Germany, and we've been here for about 9 years at this point. I'm also executive chairman of GenH2, and that's really what I'm here to talk to you about today. As I've seen the other presentations that HYSKY has put on here, there's so many great companies and great technology in the hydrogen aviation space. And I really think that GenH2's technology is so complementary and critical to hydrogen for aviation and hydrogen for many different hard to decarbonize sectors. It's so critical, GenH2's technology and equipment. So I'm really excited to talk to all of you about that today. Without further ado, let me jump in. So as I mentioned, Path to Hydrogen is the parent company of GenH2. It is headquartered here in Germany, and GenH2 is a 100% subsidiary of Path to Hydrogen. As I mentioned, we used to be called Philomaxcap. We are literally in the process right now of changing our name. So you may see both of those for a little while, but Path to Hydrogen is the future name of the parent company. We completed the acquisition of GenH2 earlier this year, and I'm very excited to continue with the company's commercial deployment in North America. And we're now moving with purpose into Europe and into Asia Pac. I always find it useful when I talk about, this group is very tuned into hydrogen, but I always like to tell other, analysts or investors or people that are new to the space what GenH2 is and what it isn't. I refer to GenH2 as a specialist in midstream hydrogen technology and equipment. So we are not upstream. We don't produce the molecule. Everybody talks about the different color wheel of types of hydrogen. For our sake, we focus on once that hydrogen is produced, we then liquefy it through many different sizes and types of liquefiers. But most importantly, and what GenH2 is really known for, is our ability to transfer and store that liquid hydrogen without any losses. And I'll go into more detail about that. Once you can achieve zero loss transfer and storage of liquid hydrogen, it really addresses one of the major pain points of liquid hydrogen, because there are so many benefits that I'll talk about shortly. But one of the key drawbacks up to this point has been the boil off and venting losses that I'll go into more detail during this presentation. So a quick overview of GenH2. It is a company that's been around for about 4 or 5 years. It is headquartered in Titusville, Florida, which, as many of you know, is the home of NASA's Kennedy Space Center. And there's a reason that it's headquartered in Titusville, Florida. It has deep ties to NASA. In fact, one of my favorite statistics about GenH2 is that in the history of NASA, there are only 45, it used to be 42, but a few just got inducted. There are 45 NASA Inventor Hall of Famers. GenH2 has 2 of those Hall of Famers on staff, and one of them is one of only 5 women to have received that designation as a NASA Inventor Hall of Famer. So we are quite proud, and it shows the depth and our ability to really punch really far above our weight when it comes to our ability to understand liquid hydrogen, work with liquid hydrogen, and know what it takes to transfer and store it without any losses. Our footprint basically is most of the folks are located in the US and in particular in Titusville, but we have offices in Berlin, Germany, where I am, as well as a small office in Seoul, Korea. So I mentioned this earlier. I always like to think about it in terms of what problems is GenH2 solving. So 2 of the problems as we think about it are, 1, the liquid hydrogen supply chain is losing 30 to 50% of the hydrogen delivered. Now, that's not just us saying that. Many of you have probably seen the recent article that came out by David Lease in H2 View. David Lease was the station czar for Nikola. And prior to Nikola's unfortunate demise, they were working very heavily in the space of understanding liquid hydrogen stations and the liquid hydrogen supply chain. And David Lease came out and said they were losing 50% on average of the hydrogen that was delivered to the point it was going onto their trucks. That statistic is not just anecdotal. We're hearing it from many of our customers in California, in other places in Europe. Some of them say that there are different percentages of losses depending on the equipment that they're using, the volumes that they're getting, and the pressure that they're letting their tanks go up to. But 30 to 50% really is the amount of liquid hydrogen that is lost from transfill to storage and into the dispensing interface through the cryopump. So GenH2's equipment, as I mentioned, can eliminate those losses through its patented and proprietary controlled storage approach, which I'm going to tell this group about today. The second issue with liquid hydrogen is really limited to production in certain very large hubs, mainly owned by the large industrial gas companies. And their business model, I spent almost a decade at Air Liquide, so I understand the business model of the industrial gas companies. Their business model is to build large hydrogen liquefiers. You know, you're typically talking today 15, 30 tons per day. That's sort of the sweet spot for industrial gas companies building hydrogen liquefiers. And their business model is to sell those kilograms of liquid hydrogen for the very highest amount that they can to meet their internal, return on capital employed numbers. GenH2 approaches this a little bit differently. So GenH2 has technology to not focus on these regional hubs for hydrogen liquefaction. In fact, GenH2's technology and equipment focuses on small to medium to sort of small industrial scale hydrogen liquefiers, anywhere from 20 kilograms a day up to roughly 5 tons per day. And I'm going to go into some of the advantages of that. But when you take a big step back, the real difference in the value that GenH2 is bringing to the marketplace is you can place these hydrogen liquefiers either directly at the point of production. So think of an electrolysis facility or a hydrogen pyrolysis facility. any way that the hydrogen is produced as a gas, you can put a GenH2 liquefier right there to liquefy 100 kilograms a day, 1 ton per day, 2 tons per day, 5 tons per day. It's very flexible and modular, and really brings a lot of advantages because you can do this liquefaction at the point of production or at the point of use. So I don't probably have to go into too much with this audience on why liquid hydrogen versus gaseous, but there's a couple of these that I would like to have the group think about today. Obviously, liquid hydrogen has much, much higher density than gaseous hydrogen. It's much more efficient in transportation. Its ability to scale. I think earlier presentations have even talked about the fact that gaseous hydrogen is very good for what I'll call demonstration or small use cases. But once you really want to scale up to dispensing 1 ton per day or 2 tons per day or even more, liquid hydrogen makes a ton of sense. Otherwise, you're going to be running tube trailers out to this location, essentially 24 hours per day. The duty cycle isn't great, and there are many, many maintenance issues and more components when you're talking about gaseous hydrogen. With liquid hydrogen, it gives you a lot of flexibility to have fewer components, to have much more reliability to your operations, but also have the ability, you then have the flexibility once it's in liquid form to dispense as gas or to dispense as cryocompressed or to dispense as liquid. But you don't have that flexibility if you start with gas. For this group today, when we're thinking about aviation in particular, this next point is of utmost importance, and that's the safety. Gaseous hydrogen, again, I'm preaching to the choir here, I realize, but gaseous hydrogen is kept at 350 bar, 700 bar, sometimes 900 bar, whereas liquid hydrogen is kept, at very, very low pressures, which means if you want to set up infrastructure for airports or marine ports or places where you really have to think about blast radiuses and what can be placed near something, and can it be placed in an operation where thousands and hundreds of thousands of people are transferring at an airport near there. Liquid hydrogen is the answer because of its low pressure. I also mentioned purity. So anytime you go to liquid scale, you're essentially getting rid of all the contaminants in the hydrogen and you're getting 5/9 purity. Gaseous can become that, but is not always guaranteed. And if you want to be running hydrogen across a fuel cell, you're going to want 5/9 purity guaranteed. So you really need to be focusing on liquid at that point. This is the slide I sort of change when I'm talking to my European friends. We have a football field, or soccer as we call it in North America. And I have a NFL football field when I'm talking to my American counterparts and countrymen. But this is a good demonstration of the footprint associated with the same amount of gaseous hydrogen and liquid hydrogen storage. So liquid hydrogen for aviation. There's been some very, very interesting studies out there. And, a lot of the discussion has been around Airbus and how quickly or slowly they're going. But there are a lot of benefits when you think about hydrogen for aviation. I think Danielle has covered these in a number of presentations, and others in the industry have talked about the range that comes with using hydrogen. But I also thought it was interesting that some of the recent articles that have come out have not just talked about liquid hydrogen or hydrogen versus batteries. Obviously, there's advantages for range for hydrogen in that case. But even when you think about liquid hydrogen, or I keep saying liquid hydrogen, when you think about hydrogen as opposed to SAF or e-methanol, hydrogen really has a lot of advantages other than, very long haul flights. Hydrogen head to head beats both of those when you think about what you want to employ on the plane. Liquid hydrogen itself has all of the energy density, the ability to scale up. You don't have to modify the airport infrastructure all that much, given the fuels that are being used today. eSAF is very much thought of as sort of this plug and play replacement. But folks have been trying to make eSAF for a long time and make it viable and make it clean enough. And hydrogen, especially liquid hydrogen, answers both of those questions, again, without having to make major modifications to the airport infrastructure. It's our position that there's a lot of opportunities for regional airports as liquid hydrogen or hydrogen becomes, the preferred use case, for all the reasons that I talked about. You can go liquid to compressed gas. You can go liquid to liquid directly on board with onboard tanks, which we think is very, very interesting. Direct fueling on the aircraft is available. Folks have talked about refueling of fuel pods. You can think about solid state storage from liquid hydrogen into metal hydrides or something else if that's the type of tank you want to put on board. But essentially, once it's in liquid form, you have all the options in front of you. As opposed to if it's in gaseous form, you're very limited in terms of your ability to apply it at large scale to infrastructure, your ability to fuel in different modalities. So liquid really, in our minds, is the right midstream medium when you're thinking about aviation. Okay, so high level, when you think about airports and infrastructure, you have to think about how do you get the hydrogen to the airport in the first place? Are you taking it in by pipeline? Are you creating it on site by having electricity go to electrolysis facilities? Are you trucking it in with liquid hydrogen? Or are you producing and liquefying it on site? So there are different ways to think about doing that. But, getting the liquid to the airport for the infrastructure so that it can be put on the airplanes, but also so it can fuel all of the different vehicles around the airport itself, is very, very key. Okay, so let's get into sort of the flagship product of GenH2, and that is the controlled storage. And I'm going to tell you what I mean by controlled storage because from GenH2's perspective, there are a lot of companies out there that talk about their ability to prevent boil off. But most times, they're talking about boil off gas compressors or capturing boil off gas from tanks and potentially reliquefying that. I'm going to tell you why GenH2's solution, which is active refrigeration and preservation of the liquid hydrogen, is different from, and in our opinion, head and shoulders better than some of the other solutions that have been brought to the table thus far. So I apologize. This is a busy slide, but I spend a lot of time talking with folks about our technology, and I feel like this is the best way to describe it. So the top panel is essentially how the liquid hydrogen value chain exists today. You have a liquid hydrogen tanker truck and let's call it 4,000 kilogram truck or tank, just to be, talk in broad brushes. That liquid hydrogen tanker truck pulls up, delivers its 4,000 kilograms into a liquid hydrogen bulk storage tank. That bulk storage tank then goes into a cryopump. That cryopump goes to a dispenser, and then that gets put on board some type of vehicle, bus, airplane, forklift, heavy duty truck, Toyota Mirai, you name it. What has been proven through many different studies and from testimonials by not just David Lease at Nikola, but many, many different companies in papers and in white papers and in discussions is these operational losses of 30 to 50% of the hydrogen. It's fair to say that you can't have an economically run industry when you're losing 30 to 50% of your core product or your fuel. And so GenH2 was really developed out of this deep history at NASA because I want you all to think back in the 80s and 90s when the space shuttle was launching and they were using liquid hydrogen. What NASA found was they were losing 50% of the hydrogen before they could put it on board the rockets. And so the cryogenic test lab at Kennedy Space Center, led by James Fessmeyer, who is GenH2's chief architect, they were tasked with finding a way to prevent those losses. And what was developed at NASA and has been evolved by GenH2 into what you're seeing today with GenH2's controlled storage is active refrigeration and preservation of that liquid hydrogen in its liquid form so that you're not having the boil off, you're not having the venting, and you're really not having to come up with these less than ideal solutions of capturing gas and spending a very large amount of energy to reliquefy it. Okay, so I've described what's happening today. So the GenH2 liquid hydrogen value chain is different. Yes, you still have the same tanker truck delivering 4,000 kilograms of liquid hydrogen into the bulk storage tank. But that bulk storage tank has now been GenH2 enabled. And let me tell you what that means. So you see inside the tank what looks to be, it's a heat lift assembly. I describe it to sort of the novices in hydrogen as thinking of a bird cage with hollow tubes. And that bird cage is hollow because it's attached to a cryogenic refrigerator, which I'll show in more detail in later slides. But this cryogenic refrigerator uses its cold power to circulate gaseous helium through this heat lift assembly and preserve that liquid hydrogen at the ideal temperature. Obviously, negative 253 Celsius is the boiling point for liquid hydrogen. So this cryogenic refrigerator, using this closed loop of helium, can circulate this gaseous helium through the heat lift assembly, maintaining, dynamically maintaining that liquid hydrogen at the ideal temperature and pressure. So not only does it prevent the transfill losses, it prevents the daily storage losses, and it delivers very, very high quality, cold, dense liquid hydrogen into the cryopump interface so that it prevents the cavitation, the bubbling, when it gets into that cryopump, so that if you're delivering 4,000 kilograms from this liquid hydrogen tanker truck into a bulk storage tank that's GenH2 enabled, you will be dispensing 4,000 kilograms, whether that be in gaseous form, cryocompressed form, or liquid form into your vehicle, airplane, forklift, you name it. So this is really the difference. This is all patented. This entire system's patented. The heat lift assembly, the smart tank and the sensors, all of that is proprietary, patented technology and equipment that is manufactured by GenH2. After showing those two panels, what I really like to talk to folks about is this picture on the right here is actually a picture of a transfill from a liquid hydrogen tanker truck into a bulk storage tank. And this is typically, without GenH2 technology, this is typically what you'll see, which is a large amount of venting when the very cold liquid hydrogen from the tanker truck goes into a tank that probably is holding 25, 30% liquid hydrogen, with the rest of the tank being gas and ullage. And there's a vapor eruption, and that builds up the pressure. It sort of self-pressurizes inside that tank, reaching a level to where the valve has to open up. And this is essentially dollars or euros, depending on your viewpoint, flowing out the top of the tank, and it's being wasted. Now, that's just this point, the transfer loss, right? But that can be a very large part of the loss. And if you're experiencing that 30 to 50% loss over and over and over again, that's one of the reasons you see the price of hydrogen at the pump in California be $30, $35 a kilogram, because you can't compete with diesel, for example, on price if you're losing 30, 50% more or more of your core fuel product. Okay. So I talked about this as active controlled storage. I just wanted to give you an idea of what the heat lift assembly looks like. It is a metal structure that goes inside and sits in the liquid hydrogen portion of the inner tank of these bulk storage tanks. We work with all the largest bulk storage tank manufacturers. We don't make the tank ourselves, but we do make the heat lift assembly and the cryogenic refrigerator. Those are both manufactured by GenH2. As I mentioned, it's a closed loop helium circulation unit. It prevents all boil off and venting. And I always talk about the and venting because the boil off, when a lot of people talk about boil off, they're really just talking about this daily storage loss, or NER. And look, today's tanks are very, very good. Let's call it 1% a day losses. And if you have an active station, that 1% it's not nothing, but it's also not where the biggest losses happen. They're typically happening at the transfer and into the dispensing interface. But it's all going to depend on the frequency of your fills and some other factors and your components, obviously. Good. So this is a little bit what the RS-1500, that's what we call it, the RS-1500 controlled storage unit looks like. Now, this is a 2-skid design. We can also do a 1-skid design if there is cooling water available. But I just want to mention it's a very, very small, easy to work with footprint. And in this instance, you have a vertical tank. It doesn't matter to us if it's vertical or horizontal. But this one's vertical, and the heat lift assembly is inside this tank and is connected to the cryogenic refrigeration unit. Good. Now, quickly, I want to talk about GenH2's liquefaction. I also think this is an interesting differentiator and something that is very applicable to hydrogen for aviation. Again, if I were to take a big step back and think about, I saw that a number of folks are also from Europe here. Some folks from Germany and from Spain were on the call. Liquid hydrogen availability is a big issue. The US, if you think about it right now, has roughly 350 tons per day available and being produced in the US. That's by big producers like Air Liquide, Air Products, Linde, Plug Power, and a few others. Europe, on the other hand, has roughly 30 tons per day only available. So, there's a supplier in central Germany, there's one in northern France, and there's one in the Netherlands, in Rotterdam. There is discussion about having more hydrogen liquefaction available in Europe, but right now it's 10% of what's available in the US, and more of that needs to be available. Some of the things that have stopped more liquid hydrogen being available in Europe is a real differentiator for GenH2, and I'm going to talk about that in a minute. I just want to sort of set the stage for that. One is the CapEx for very large 30-ton per day facilities. That's going to have to be borne typically by the Air Products and Air Liquides and Lindes and Messers of the world, for them to come up with, I think the last one that Air Liquide built in Las Vegas, they were talking about $250 million of CapEx investment to build that facility. That's a long process. That's a big decision to make, to invest that amount of money in a large hydrogen liquefier. And for customers in Europe in particular who want liquid hydrogen and need liquid hydrogen, especially for aviation, they're not in a position right now to build their own 30-ton per day liquefier. And if they only need 100 kilograms a day to test their, eVTOLs or their planes, or maybe they want to graduate up to 500 tons a day or 1 ton per day, it's difficult to get that delivered from the limited amount that's available in Europe. So what GenH2 has, we've approached this a little bit differently. As I mentioned, we have different sizes of sort of flexible modular hydrogen liquefiers. I think of it as 20 kilograms a day, up to 100 kilograms a day, and then you get into the 1 ton, 2 ton, 5 tons per day. Between 100 kilograms a day and up to 5 tons per day, the beauty of GenH2's approach is there is no liquid nitrogen pre-cooling needed. Now, we can use liquid nitrogen for pre-cooling if it's available, but if it's not available, GenH2's Brayton cycle liquefiers do not need liquid nitrogen pre-cooling. So some of you may be asking, why does that matter? Well, the reason it matters is because for every kilogram of liquid hydrogen produced, you need 8 to 10 kilograms of liquid nitrogen for pre-cooling when you're using these Claude cycle liquefiers, which is typically the cycle that's used for 15 tons a day and 30 tons per day. So if you have a 30 ton per day liquefier, which that's what Air Liquide has in Las Vegas, that's what Air Products is talking about building in Rotterdam, you need to have 8 to 10 times that amount of liquid nitrogen available to make that liquid hydrogen. You need that liquid nitrogen for pre-cooling. GenH2's technology does not require that. So it really gives GenH2 the equipment, the ability to be sort of plug and play. Think of it, if someone has a green hydrogen in an electrolysis facility and it's near an airport, and that airport really wants to have liquid hydrogen infrastructure at the airport, you can put a hydrogen liquefier right at the point of production using GenH2's Brayton cycle liquefiers, and there is no need for liquid nitrogen pre-cooling, and therefore the owners and operators, whether it's the airport itself or the owner of the source of gaseous hydrogen, can employ the use of liquefaction, and it makes it much more flexible and sort of brings it to the masses, as opposed to waiting for the industrial gas companies to go through their process and build some very large sort of regional hub liquefier. GenH2 gives people the ability to put it either at the point of production or at the point of use. It's very low pressure. It's very high purity. It's very safe. It's a great solution for aviation. What I'm showing you now is what we call the LS20. That's a 20 kilogram a day liquefier. GenH2 built this in a mobile format, which is a really interesting concept for folks that want to think about, hey, I'd like to be launching, liquid hydrogen powered drones or gaseous powered hydrogen drones or eVTOLs. 20 kilograms a day or 100 kilograms a day is a really great solution to get started. So GenH2 has solutions for all of those sorts of use cases. This is a sort of a quick schematic of the components that would be involved for a 1 ton per day liquid hydrogen, a hydrogen liquefaction unit. Again, closed loop, helium cooled system, no liquid nitrogen pre-cooling required, and you can turn it up and down depending on your use cases. One of the great things about the GenH2 liquefiers as well is that when GenH2 makes a liquefier, you're obviously going to need somewhere to store that liquid hydrogen once it's made. And GenH2's zero loss controlled storage essentially comes with a GenH2 liquefier when you're thinking about 1 ton per day and up. So you really sort of almost get controlled storage for free when you're ordering a GenH2 liquid hydrogen liquefier. I hope that this has been of use for folks on this call. I know there's a lot of liquid hydrogen or hydrogen aviation enthusiasts and folks in the industry, and we're really excited at the Path to Hydrogen level and at the GenH2 hydrogen level to be talking with all of you today. So at this point, Danielle, I'll open it up for questions.
Awesome. Thanks so much, Josh. That went by so fast. I appreciate the quality of the content. Very exciting. And that slide that you mentioned was kind of busy. Was my favorite slide. I spent like 30 minutes looking at it last night. So really good job. We have lots of questions. Let me go in the chat, and I am going to I'll do my best to go in order. Of the order they came in, and I'm going to ask that you all come on and ask the question. That way the people watching the recording can also hear the question. Okay, so the first one I see, okay, apparently there wasn't audio with my video. Sorry about that. That was a new test. All right, so Sarah, you're up first. Per usual, I love your enthusiasm. I think you might have had a couple of questions, but the adoption rate of liquid, if you want to ask that question.
I think she had to leave
Sarah
the meeting.
She had to go to another meeting.
Yeah, I think she dropped off.
Okay, thanks, Jay. Sarah asked, what is the adoption rate of liquid hydrogen in airports in Germany? Any pilots being executed? Okay, yeah, obviously not pilots in an aircraft. That people were kind of joking about that in the chat, but I think you get the question.
Yeah, let me speak about Europe generally versus Germany. So I would say there's a lot of interest for. I'm going to take a big step back. So, from my, North American counterparts, I would say, being an American living in Europe, hydrogen is thought of very differently here. Hydrogen is not just thought of as sort of a nice to have and an energy transition tool. Hydrogen is really viewed from a national security standpoint, an energy security standpoint, because of the war in Ukraine. And so, as Russian natural gas has gone away, Europe really made a decision to double and triple and quadruple down on hydrogen being the backbone of the energy transition. So I just wanted to set the stage to say it's a necessity. It's something that the EU is focused on, and each member state is forced to come up with their plan to say, here's how I'm going to meet all these RED 3 directives for transportation, for industry, and other things. So just to sort of put it in context as to what's happening in Europe. But there are a number, to the question, there's a number of airports that are starting with pilot programs for hydrogen and liquid hydrogen. And I know that the Rotterdam airport is moving quite quickly on this. Both the Port of Hamburg and Hamburg Airport are also quite focused on the use of liquid hydrogen. But Schiphol Airport is focused on it. Trying to think of other ones around Europe. France, Toulouse Airport is another one that is very big on hydrogen and liquid hydrogen. So there's a lot of uptake for hydrogen, and I think, look, California sort of went through this evolution of everybody started with gaseous hydrogen. All the refueling stations were gaseous hydrogen, and it is fair to say that there is not an RFP that comes out now across the board in California that is not liquid. Everyone understands and has gone through the pain and the growth of how gaseous hydrogen works, the pros and cons and the headaches and the losses and the duty cycle and everything else. So liquid hydrogen is just the standard. Europe is a little bit behind that, but I think getting there very quickly. And liquid hydrogen is just starting that ascent into the #1 position.
Thanks for sharing that. That's so interesting. A lot of us in aviation tend to think onboard the aircraft, and we know that it's much more dense than gaseous. And then we understand boil off is an issue, but I've never heard it explained in a like in a functionality on the ground for infrastructure. So that's actually, I think, the first time I've ever heard that. That was a very valuable point that you just made. Okay, next question is Conrad. Would you like to come on and ask your question?
Yes, sure. Thanks, Danielle. So my question was trying to understand in terms of percentage the actual energy use. And the question was, what's the electricity cost of the refrigeration unit, translated into a percentage of the stored hydrogen if it were used in a fuel cell to generate the electricity needed for the refrigeration unit. So basically, if you were to take some of that hydrogen, use it on a fuel cell, power the refrigeration unit, how much of that hydrogen that you're storing would be used, to get a good comparison? Like, would it be like 5% instead of 50% loss? Would it be 1%? Do you have such a number?
Yeah, it's an interesting question. You're sort of talking about how could the boiled off hydrogen be used to power the cryogenic refrigeration unit. We don't really think about it that way, Conrad, because, and it's a good question, but I'm going to give you some other information in a minute. Let me tell you why we don't think about it that way. Because of GenH2's ability to preserve the liquid hydrogen, it eliminates the losses. So, most people are thinking of, what do I do with that boil off? Do I capture it? Do I use it for some other process? With GenH2's technology and equipment, there are no losses. And so it's tough to think of how do I want to use those losses if there aren't any. To your specific question in terms of course, it uses electricity to power the active refrigeration. And, we've run the CapEx and OpEx numbers very specifically, and it is relatively low power. It's not zero power, but when you look at it as a percentage of the savings that you get or the opportunity to sell the hydrogen that would have otherwise been lost, the OpEx is a very, very small fraction of the savings as compared to the 30 to 50% losses. OpEx is a very, very small fraction of that. So what I always tell people is, and we have, lots of spreadsheets to talk with customers about this. When we run the ROI numbers on CapEx and OpEx versus the hydrogen that has been preserved and not lost, it becomes one of those no-brainer approaches where people realize, gosh, for the CapEx and OpEx involved with GenH2's equipment, I have now the ability to sell thousands and thousands of kilograms of hydrogen that I would have otherwise lost. It's a no-brainer to include this equipment in the whether it's a hydrogen refueling station or some sort of midstream application for maritime or aviation or something else. Hope that answers your question.
Yeah, the second part does. Many thanks. Yeah.
Sure, you bet.
Thanks. David, I do see your hand up. Let me get to a couple more questions in the chat. And while I'm pulling up the next question, I have a question for you, Josh.
Sure.
I hope this isn't controversial. What's the difference between you and NeoX?
I didn't hear the last part of the question, Danielle.
What is the difference between what you all are doing and what NeoX is doing? NeoX Systems. Are you familiar with them?
I'm not familiar. Maybe I should be, but I'm not familiar with NeoX. What do they do?
They liquefy hydrogen.
Oh,
NeoX Systems, Mark Haberbush is the CEO. Definitely, I don't know if you guys would complement each other or be competitive, but yeah, and maybe Cody, if you're still on the call, maybe Cody knows the answer to that. Okay, let's see. Lots and lots of questions. Let me see. I just did Conrad. I think next we have Samantha. Samantha, would you like to come on and ask your question?
Sure. Thanks for the opportunity. Nice presentation, Josh. Thank you for sharing everything.
thank you.
If you run numbers through, at what point and what quantity of hydrogen does the liquid system that you have with all of its zero loss processes in place become more economically viable over gaseous hydrogen delivery? Just looking from a small operator or a small airplane operator with not large quantities of hydrogen required on a daily basis.
And just to be clear, Samantha, you're talking about hydrogen liquefiers or controlled storage or both?
The entire system, right? For me, if I was a small aircraft operator with a little bit of quantity required, I'm not worried about the entire system. I just want the delivery cost of hydrogen. At what point does your system, at what quantity of hydrogen would you suggest that we look at your system over a simple gaseous system that can come in a gaseous tanker, drop off a little bit, go to some other place, and still give me at a decent price?
Again, it's tough to say just, a hard and fast rule on that because let's take hydrogen aviation for a minute, just generally. We at GenH2 were talking to a lot of customers around the world for different types of use case applications, whether it's for putting in an onboard tank as gaseous hydrogen. So they just want to use liquid hydrogen as a midstream medium because of its density and transportability and storage capabilities with a smaller footprint and safety and those sorts of things. So I'm not sure they think about it necessarily in terms of I have to have 20 kilograms a day of requirements or 100 kilograms a day of requirements or something like that. there's a lot of factors that go into it. So a lot of our customers are saying either they're in a country or jurisdiction that just doesn't have liquid hydrogen readily available, and they want to have it available. So they come to us and say, hey, I need to be able to test and run our aviation, our eVTOLs or our planes, whatever it may be. We need to have 100 kilograms. I need 70 or 80 kilograms a day. And so we're able to say, okay, well, we have a 100 kilogram a day liquefier, assuming they have a source of gaseous hydrogen, and we can put that either right at the point of production of the gaseous hydrogen, and we can truck it over and store it at your site, or you can bring the gaseous hydrogen right to your location, and we can liquefy it right there on site. So there's a number of different factors that go into it, but it seems to me, based on the experience that we've seen in discussions with our customers around the world, that 20 kilograms a day is sort of the really beginner stage. And I would say most folks start to think about having their own source. They start to think about it 20 kilograms a day, but they start to very quickly then think about 100 kilograms a day, or maybe they're sharing it with another company at 100 kilograms and then giving themselves the ability to grow into that 100 kilograms, because they can always come back to us and we can double it and give them 200 kilograms a day when they need it. So there's not easily a rule of thumb on a kilograms per day basis to say this is when you'll need it.
Thank you.
Yeah, sure.
Yeah, and I would just kind of add to that. Samantha, if you don't think you'll need more than what you're using or need to scale bigger or larger aircraft, it wasn't exactly a podcast. I did a webinar with Matt Moran a couple of years ago, and we discussed like when liquid and when gaseous. And sometimes it does make sense to use gaseous. If you're just doing a
Sure.
small drone and you don't think that you really need much more and you're not trying to scale up, then you certainly can do that. So, kind of looking at the mission as well. But I think a lot of us, eventually we kind of realize like we do need to go to liquid. And so if we start thinking about liquid early on, then it makes scaling much easier. Kunj Patel asks, and you're more than welcome to turn your mic on. Your question is brief, so I can read it, but you're more than welcome to turn your mic and camera on. What materials were used in building the tank?
Well, again, we're not tank builders ourselves, so we don't produce the liquid hydrogen bulk storage tank. We've already announced a public partnership with Taylor Wharton, and we're going to work, we think, with the largest bulk storage liquid hydrogen tank makers globally to sort of make their tanks GenH2 enabled tanks, which will mean either building new tanks with our heat lift assembly inside, or retrofitting existing tanks with our heat lift assembly and then attaching it to our cryogenic refrigeration system. So, the tanks that are made by Taylor Wharton, for example, who we work with almost on a daily basis, they make and sell tanks all around the world. And those tanks are, the best liquid hydrogen storage tanks on the market. But if you were to put them out there on their own, at a liquid hydrogen refueling station, for example, these days, or a refueling station at an airport, the whole system, transfill, daily storage, and transfer into the dispensing interface, you're still going to be experiencing the 30 to 50% losses. With GenH2's technology and equipment, those losses are eliminated.
Thank you. Next, Albert, would you like to come on and ask your question? Albert Gill. Yeah.
Yeah, thank you, Josh. Great presentation. I was wondering, because the system that you're introducing inside of the tank can handle the energy that's entering the tank through daily, it can handle the daily boil off, but how do you handle the transfer losses? How do you handle the pre-cooling of the line to claim that you have zero boil off in the transfer processes?
Good question. And I appreciate that. That is that's an important point. I brought, hopefully, Danielle, can you guys see my screen again? I tried to bring that up.
Yep.
Okay, great. Albert, it helps me to kind of come back to this to talk about how we do it. And again, this is a busy slide and I went through it fairly quickly. So bear with me for a second. What you're talking about is sort of this daily storage loss, right? You put the liquid hydrogen into the bulk storage tank, it sits there, and at all times it's being attacked by heat from the outside. And as well designed as these liquid hydrogen bulk storage tanks are, that constant attack by heat, the liquid hydrogen eventually is going to, the temperature is going to increase, the pressure inside the tank is going to increase, and then you're going to have to vent. So that's sort of your daily boil off. I've also talked about this transfill loss when you're taking cold liquid hydrogen from the tanker truck and you're putting it into the bulk storage tank. And that bulk storage tank is likely, at 25%, 30% full. The tank is very warm at that point. And so when that liquid hydrogen, very cold liquid hydrogen, I guess depending where you are in the milk run with this tanker truck, but let's assume you're the first delivery of the day and you're getting 2,000, 2,500 kilograms put into your liquid hydrogen bulk storage tank. That very cold liquid hydrogen going into that warmer bulk storage tank causes this vapor eruption. Again, so then you're building up pressure inside the tank. And what you really end up with is this picture here where you're just venting gaseous hydrogen out of the release valve at the top. You also have losses, as I mentioned, into when you're pumping the liquid hydrogen into the cryopump. If you're delivering, so in this top picture, if you have liquid hydrogen sitting in this non-GenH2 enabled tank, so there's no heat lift assembly, there's no preservation of the liquid hydrogen, you're pumping saturated, low quality, warmer liquid hydrogen into the cryopump, and those cryopumps suffer from cavitation at that point, which means bubbles as they're pumping this low quality liquid hydrogen. And again, it's hard to say here's the exact percentage because it depends what is the pressure and temperature in the tank, what is the quality of the liquid hydrogen coming into this cryopump, but there's a lot of losses that occur at this stage. So moving down to this lower panel, when you have the heat lift assembly inside the tank and you have active refrigeration, you're circulating that gaseous helium through the heat lift assembly, on this dynamic basis, because this tank at this point is a GenH2 smart tank. It has sensors throughout the tank to be measuring temperature, pressure, and a number of other data points fed into our software so that it can circulate the exact right amount of gaseous helium and keep that liquid hydrogen at the exact right temperature so that it prepares the tank for this transfill, it prevents the daily storage loss, and it delivers very, very high quality, dense, cold liquid hydrogen into the cryopump, which really reduces the losses associated with cavitation. So what that really means then is throughout these three steps, you're able to deliver liquid hydrogen into a very well prepared, cold liquid hydrogen bulk storage tank, and then pump very high quality liquid hydrogen into the cryopump, ultimately dispensing it into your vehicle of choice, with all the liquid hydrogen that you delivered. Hope that answers your question.
Yep, thank you. Thank you very much.
Thanks, Albert.
Very interesting. I noticed the first time you were talking about this slide, you said helium, and I thought you meant hydrogen, but I noticed you said it again. Could you explain the role of helium in this process?
Absolutely. I'm glad you asked that. So I do go through this slide quickly, and that's a very, very important point, this helium closed loop circulation. So this cryogenic refrigeration unit that's here, right? It generates, let's call roughly 1,000 watts of cold power. And it uses that cold power to, instead of producing liquid hydrogen, this cryogenic refrigeration unit uses that cold power to circulate gaseous helium through the heat lift assembly in a closed loop. So you're not losing the helium. But when you think of elements out there in the universe that have a lower boiling point than hydrogen, helium is one of the only ones out there. There's a couple of others, but helium is a really good use case here because its boiling point is below hydrogen, but close enough to it so that you can circulate gaseous helium through this heat lift assembly, cool down the liquid hydrogen to the exact temperature and pressure that you want without losing any helium in this cryogenic refrigeration unit. So it's a very elegant, very deeply engineered process that GenH2 has patented based on this history from NASA's Kennedy Space Center. So James Fessmeyer and Martha Williams and others were working on this for decades before GenH2 ever came into existence. But this technology and equipment, in our minds, is critical to this liquid hydrogen midstream use case so that you can really, at the end of the day, have hydrogen compete with whether it's diesel or aviation fuel or SAF or whatever it may be on price by not losing 50% of your core fuel product, preserving that. And then, once production costs continue to come down for hydrogen, we think that our controlled storage is going to be ubiquitous.
Fascinating. On this, and apologies to folks asking the questions. I have my own questions. Okay, so you have, I'm going to get back to the questions. We do have time, but so you have liquid hydrogen going in to the tank. What if you were starting with gaseous? Could you put gaseous into that tank, or do you need to first liquefy it and then put it in?
You have to liquefy it first.
Okay.
Yeah. So I think that, as I mentioned earlier in my talk, there's a number of folks that have talked about, hey, we can prevent boil off, or we're boil off free. And I want to really distinguish what is out there in the market versus what GenH2 does. So there's a lot of folks that talk about, hey, we prevent boil off. Really, all they're talking about typically is this daily storage loss. And the way they go about it, whether it's with boil off gas compressors or other types of, boil off free solutions, is all they're really doing is capturing that gaseous boil off and either putting it into a gaseous storage tank or even sometimes reliquefying it and trying to put it back in the bulk storage tank. And, my colleague Cullen Hall has told me multiple times, I'm going to see if I can remember these statistics correctly, because there's probably people who are, much more deep on the engineering side than I am. But it takes 18 to 20 times the power to reliquefy gaseous helium back into liquid than it does to use GenH2's system to simply preserve that liquid hydrogen using our approach of circulating helium. So I want to say that again. It takes 20 times more power to reliquefy it from gas than it does to just preserve it as liquid in the first place.
Perfect segue to the next question. And Richard, please come on. I was hoping that you would chime in, and feel free to tell the audience where you're from and who you're with, etc. Richard Fu.
Oh, okay. All right. Thank you, Danielle. And thank you so much, Josh, for the excellent presentation. And first, I would like to agree with you that the hydrogen must be the energy backbone of the, especially for the renewable energy. So now my question, actually, Conrad and I forgot, was it the Albert who asked the questions? They asked the questions I had, but another question I have is, what is there a way for you to retrofit existing tanks and install the RS-1500? And I would like to know the ROI, especially like, if it's going to be like, a lot of CapEx, we would like to know, what is the ROI we can expect to get?
That's a great question. And, it's funny, Richard, we were asked that question as to whether a customer would need to buy a new tank or if they could retrofit existing tanks so many times that while at first we would tell people, look, you just need to buy a new tank and it's going to have the heat lift assembly built into it. We worked with our partners after getting that question probably for the 8th or 10th time and said, we need to come up with a solution for existing tanks. So the resounding answer is absolutely yes, we can retrofit existing tanks with our heat lift assembly. We've talked with our partners about it. They're very, very confident on their ability to do that at a reasonable price. Now, again, it's going to matter a bunch of different variables as to how people want to do this and how far you have to ship the tank. And you ultimately have to decide, is the juice worth the squeeze in getting a used tank retrofitted? But absolutely, yes, we can. And we're excited. We're working on our first projects on doing that right now. The second part of your question was around ROI. And let me just sort of give you a sense on this, because I'm really trying to be precise with my answers, but sometimes there's so many variables involved that I can't just give a one-time, rule of thumb ROI figure. Having said that, we're very focused on giving our customers absolute transparency on when they spend the CapEx to include controlled storage in their solutions, and they're avoiding all of the losses that they've either already experienced or that they know that they will experience based on the multitude of articles that have been written about the liquid hydrogen supply chain. We're quite confident that the ROI on a particular project could be as low as single-digit months based on the losses that our customers are experiencing. Now, that is typically for a hydrogen refueling station, for example, that has a lot of activity and volume on it. Now, if you're only getting a fill once a week, for example, it's going to be a different calculation in ROI than someone that's expecting to get a refill, 5 times a week, 6 times a week, 7 times a week or more, right? Then the ROI is it moves, like I said, into that no-brainer category that you just show someone the ROI spreadsheet and they say, okay, how quickly can I order one? It's a different calculation when someone's only getting a delivery once a week, for example. But even then, it's well within the confines of what people would expect for ROI for an industrial piece of equipment, even in those lower volume use case scenarios. If you want to contact me offline, Richard, I could walk through exactly, me or my colleagues, we can walk through exactly what those ROI numbers look like, but they're very attractive.
All right, great. Thank you so much for the answer.
You're welcome.
Thanks for that question, Richard. Kunj Patel, I don't remember if we already answered this question. Would you like to come on and ask your question? I don't know if Kunj is still with us. I'll ask it. We may have already covered it, but how much energy is required for liquefaction?
For liquefaction?
Mm-hmm.
Well, it's again, it's not one simple answer on these. It's going to depend on the size of liquefier that you're ordering.
Let's say 20 kilograms.
Okay, so 20 kilograms, if I don't mind, Danielle, so below 100 kilograms, you're still talking about cryocooler technology. So if you're at 20 kilograms, you're not really trying to focus on the most efficient system. The people that are ordering 20 kilograms are typically saying, I want to have liquid hydrogen available to me on site, and I don't have that available to me because Air Liquide's not going to come out and deliver me 20 kilograms a day.
Exactly.
Right.
Mm-hmm.
But I want to have it. And so they're not so focused on getting the most efficient system on a per kilogram basis. They're just saying, I want to have it available to me because I'm going to graduate then up to 100 kilograms a day or 200 kilograms a day later.
Yep.
But if you're thinking about, let's talk about 1 ton per day, because I think that, from what I'm seeing in the marketplace, GenH2 is, if not the only one of the only companies out there offering a 1 ton per day liquefier to customers that want this. Those efficiency numbers are very, very close to sort of what the big industrial gas companies are offering. But I will caution everyone again. So, I've been on the inside. I'm sort of well aware of these kilowatt hour per kilogram numbers that are put out in the marketplace. I would just caution everyone, if you really want to compare an apples to apples comparison, I want you to think about all of the liquid nitrogen requirements that come along with a Claude cycle liquefier. So if your large industrial gas company is saying, I have this super attractive kilowatt hours per kilogram number that I'm going to tell you about, a good question would be, does that include the liquid nitrogen requirements for pre-cooling? Is that an all-in number? And I'm not sure, those numbers necessarily hold up after a bit of scrutiny. So GenH2's liquefiers are very, very close on a apples to apples comparison when liquid nitrogen is available for pre-cooling, and when liquid nitrogen is not available for pre-cooling, or the customer says, I want to put this plug and play system right next to the point of production, and there's no liquid nitrogen for 500 miles or 600 kilometers or something in any direction, and I don't want to have to truck all that in. You're not getting the exact same kilowatt hours per kilogram on efficiency, but it's still a very, very attractive system without all the capex that would go into producing, 10 tons a day of liquid nitrogen that you would need in a Claude cycle system. So I just want to sort of put that out there. Yeah.
Yeah. Let's say that I'm not super interested in comparing numbers. I'm convinced and I know that I'm going to scale up my hydrogen production and liquefaction, but I'm starting with a small gaseous hydrogen system that does 20 kilograms a day. And I just want to budget how much it's going to cost to get from 20 kilograms to a ton. Not comparing it to other fuels because I know that I want to go to liquid hydrogen. You know what I mean? And maybe that's a question for another day, but I would love to know what that looks like to kind of budget that out.
Yeah, it's a big question, Danielle. I don't know if we have time to go into all of that today, but it's the right question. It's the right question because once people sort of make that mental leap and say, I understand the pros and cons of gaseous and liquid hydrogen. I understand that liquid hydrogen is the right medium. It gives me all of these benefits in terms of density and scalability, and safety and purity and everything else. It's the right medium, right? Whether you're going to have gaseous on board or liquid on board, having liquid hydrogen in the midstream use case is the right thing to do. So one of the things that we've done after many conversations with customers is, if someone comes to us and says, hey, look, I have a need for 20 kilograms a day now, or 100 kilograms a day, but I know that I'm going to grow to a 1 ton per day system over the next 4 years. We actually have a way to offer people, look, we're going to sell you a 100 kilogram a day liquefier now. And in 2 years, when you come to us and say, I want to go to 500 kilograms or 1 ton per day, we will give you a discount on when you turn that 100 kilogram a day back to us, and we'll sell you a 1 ton per day. So we're really trying to allow people to grow into this marketplace because sometimes there's this fear of saying, well, if I buy 100 kilogram a day now and I know in 4 years I'm going to need a 1 ton per day, is the money on this 100 kilogram a day wasted? And we say, no, it's not. We will take that, we'll refurbish it, we'll sell it to a new customer, and you'll have a 1 ton per day. And it's a nice way for people to think, okay, I'm ready to jump in. Otherwise, they wait and wait and wait, and they're not able to grow their business the way that they should.
Exactly, because we talk about this so often, but a lot of folks think you have to start so big because it does need to be big for it to really to get the ROI. But you can start small. So Sue, if you heard that question that I asked, this is the very topic that I want to talk about. I sent Sue a message earlier. So you can use that little portion to brief your team. That's what I want to discuss. Okay, next question is, let's see. Albert,
By the way,
you have
I
another.
saw David Lease on here earlier, and I didn't realize I had sort of given him a shout out during my speech. So I think he may have dropped off already, but I was glad to see he was on
I'm
here.
still here.
Oh, David, well, your
There he
hand
is.
isn't up anymore.
Excellent.
Sorry about that. Do you want to, you may
Hey.
have the stage now.
No, I just could add a little color. I think it was Conrad asked the question about using the boil off to generate power. We had looked at that, and that is definitely an option to consider for part of it, but that was not going to be enough to get us to zero loss. We were looking at our best case, our most efficient site. We could run at around 30% loss, and that was around 10% during that transfer from the hauler, and another 20% when the system was operating, pumps were running for the dispenser. On the math we had done, had we put a hydrogen genset on site, it could have powered the entire system using about 7 to 10% of that, about a third of the lost hydrogen, a quarter to a third. We weren't going to use all of the boil off. So there was going to need to be something like the GenH2 system to subcool and keep the remaining hydrogen cold in order to preserve the loss. So I think it's a good option in some sites. I mean, one of the other things, we're not even getting into it here, but the grid and grid power to run this equipment is an issue at every site. And so being able to use some of that boil off for that is something to keep in mind. And GenH2 can tune, I mean, in the end, tune the system to use boil off where you can, or keep things subcooled so equipment remains efficient and you minimize the loss. So.
Yeah, thanks
Awesome.
David, for addressing that. It wasn't actually that my idea, but it's good to know that you have looked into it already and have the answer. So thanks for pointing that out.
Yeah, I think I'd love to jump 10 years from now and see what's actually been done in the field. I'm sure there's going to be combinations of all of this, and people are going to find great ways of blending technology. But I think in the end, anybody who's storing liquid hydrogen at site is going to want something like this cryogenic refrigeration unit to keep things subcooled. For the losses, and two, Josh kind of alluded to it at several points, it keeps all the equipment running more efficiently. Hydrogen pumps like subcooled hydrogen better than they like saturated hydrogen. So everything just gets better if you keep it cold.
Couldn't have said it better myself. Thanks, David.
Yes, thanks for sharing. Albert, I don't know if you went up, but I see your question says, does the GenH2 liquefier include orthopara conversion?
Yes.
Awesome. Ben, are you still on with us? Would you like to come on? Good to see you. Would you like to come on and ask your question?
Yeah, absolutely. My question is about, if you are putting a system together where you have electrolysis, on-site generation, and you are going to run your electrolyzer directly into your liquefier, what is the incoming pressure required of the gaseous hydrogen into your liquefier?
That is a great question, Ben. And unfortunately, I'm not able to answer that, although my colleague Cullen Hall is on the call. So I'm going to put him on the spot, and he can probably answer.
Yeah, so happy to answer that. We're probably, it's pretty low pressure. We can run it as low as probably about 3 bar, because the helium, because the hydrogen itself is not going through any expanders, it's just running through heat exchangers, and so we're just utilizing the helium using the reverse Brayton cycle to be able to liquefy the hydrogen itself. So you can essentially turn the hydrogen completely off and still keep the system running.
Okay, interesting. And I had another question later. I'm just going to go ahead and ask it now. How mobile is this combination of systems, the liquefier and the cooling system? For people that might want to move these systems around from test site to test site, test site to test site.
Yeah. Well, I pointed out that from GenH2 has already built this LS20, which is on wheels. So we can make We can make mobile liquefiers, that's for sure. The controlled storage system is meant to be, semi-permanent. That being said, it's skid based. So if you did want to move it from one place to another, that could be done. We intentionally designed this to be built on a skid and put on a truck if necessary.
That picture that you have right there of that mobile unit, can you give us any kind of ballpark idea about what the cost of a system like that is?
I don't have that at my fingertips. It's going to depend on the exact configuration, and we don't really put that out publicly.
Ben.
Yeah. It's a fair question. I understand why you'd ask it.
Sure.
But
I can understand. We can
yeah.
talk offline. Interesting though. Thank you.
Yeah, happy to talk offline. Thanks.
Yeah.
Great questions. I have to say, Josh, GenH2, HYSKY's been following you all for years. And I think since I first learned about you in like 2022 or 23, you guys have just been right in the pocket. You're exactly where you need to be. You definitely understand knowing your capabilities and then just becoming very good at it. So I'm super excited because
Thanks,
I think
Danielle.
this is exactly what aviation's been missing. Okay, I think the next question is George. Again, might have been something that we covered already, but I just want to make sure I get to everybody. George, if you're on, feel free to ask your question.
Is this Jörg Wimbert, I assume?
Yes.
You mean
Jörg.
by George? Yes.
Yes.
Thank you. Thank
Hi,
you.
Jörg.
Yeah, very interesting presentation. My answer is, my question was pretty much already answered. I was wondering about liquefaction efficiency because it doesn't scale non-linearly, but you already did a good job, answering that. I would definitely like to understand a little bit better your 1 ton and 5 ton liquefaction efficiencies really and how it scales. It was a good point you brought in terms of helium as well and making sure you look at all the costs, but it would be interesting to see the OpEx comparison, but I'll reach out separately. But yeah,
Yeah,
really
please do,
interesting
Jörg.
presentation.
Yeah, I'll put you in touch with our sales and commercial development folks who can walk you through that. But it really is. We designed these things to be quite competitive and there was a lot of thought put into, how we address the pain points that are out there for liquid hydrogen right now. So both on the controlled storage side and on the liquefaction side, we've really attempted to do something so that customers do feel comfortable saying, okay, I'm going to make this project go. I'm going to make this, storage and transfer. I'm going to use liquid hydrogen at my airport, at my hangar, at my test site. So we've tried to really give people the tools they need to get involved in the hydrogen aviation sector and in the hydrogen sort of mobility sector generally.
Absolutely.
cool.
No, that makes a lot of sense. Thank you. Also, somebody asked my second question as well, which was on retrofitting existing tanks. It sounded like, do you have to move the tank or could you do it on site as well?
No, we typically will send it back to
that's what it
a
sounded
manufacturing center to do it. You can't really do it on site. So you would pick up the tank and remove it. So you have to think about if it's in service, having some sort of replacement tank at the time, which is why the discussion around new tank versus retrofit makes sense for some people. If they have another tank to plug in there in the interim, or if you have 20 different sites, then you can sort of think about logistically how you might want to do it. But it's not it's not something that takes a day. It's going to take some time to send that tank to the correct yard, have the work done to retrofit it and send it back and install it.
Yeah, that makes a lot of sense. Thank you, Josh.
You bet.
Okay, I think we have time for one more. Josh, I would love to invite you to be on HYSKY's podcast because I think I could ask you questions all day. Our past guests have included Dean Kamen, Martine Rothblatt, Mikhail Cardinal. You will definitely be in good company. And upcoming, David Smith, CEO of Robinson Helicopter, who's working on hydrogen, getting ready to record that one. Okay, so last one, but I would love to have you on.
accept.
I can follow up with Sue about that. Um, Eves, I'm sorry if I'm not saying your name properly. And then I also have three quick things I need to say before we end. But the question is, what are the safety risks associated with such installation? Any measure to protect the public? Also, what about fire protection? And I think you kind of addressed this, at least with the pressure. But I'll let you add to that if you want to in our 2 minutes remaining.
Yeah, real quickly. I mean, we first and foremost made sure that our system is very low pressure, very safe. We know all the setback distances that are required for liquid hydrogen. So suffice it to say, the safety factors are incredibly positive as compared to gaseous hydrogen that's compressed at 350 bar, 700 bar, sometimes 900 bar. I mean, the PSIG levels of 900 bar hydrogen is sort of off the charts, versus let's call it 1 to 3 bar for liquid hydrogen. So very, very safe. You don't have to think about these blast radiuses that you do for gaseous hydrogen or even fossil fuels, for example. So it is quite a safe installation. Hopefully that addressed the question quickly.
Yes, I think so. Okay, I mentioned I had three things to say. One of them was inviting you to the podcast, so I did that already. Second is if you didn't fill out the survey earlier, I just stuck the link in the chat again. Please complete that. That's how we decide what courses we're going to offer next. The third thing is if you did complete the H2 aircraft certification course, I sent your certificate in HYSKY Connect. So check your chat in there and you will find your certificate. And with that, I want to send a humongous thank you to you, Josh, and to GenH2. That was a breath of fresh air. It was exactly what we needed. I think you just kind of rejuvenated the entire hydrogen aviation industry. So thank you so much for your time. We greatly appreciate it.
Thank you, Danielle. Thanks to everybody that joined the call. And, we're all super excited about GenH2's ability to work with all of you in the hydrogen aviation industry and the hydrogen industry generally. So really appreciate it.
Awesome. Thanks so much. Everybody have a great week. This will be available on YouTube later today. Bye.
Bye.